This is a recording for pre-calculus notes section 2-1 or 2.1 part 2. And if you remember, I left you with a problem to try, and that was this number 4a, given a vertex of -411 and a point -615, write the standard form of the equation of a parabola, and I commented on that S being there, but I didn't do anything about it. So for 4a, we're going to use -411, which is the vertex. So I'm going to label that as HK. We have a point on the parabola, which is -615, and I'm just going to label that XY. And then I'm going to kind of remember what my basic equation is in standard form. F of x equals a parentheses x minus h in parentheses squared plus k. And so really, when you look at that rule and those four numbers, there are 5 variables, and you know 4 of them. And f of x, of course, is equal to y. So let's just put things in and see what happens. So this is going to be y, f of x. So 15 equals, a is the only variable we don't know. X is -6 minus h, which is -4, and in parentheses squared, and then plus k, which is 11. So now we just simply kind of figure out what all this is. So we've got 15 equals a times, when I make that plus a positive, -2, -2 squared is 4. And plus 11, so I'm going to write that as 4a in a minute. Subtract 11 from both sides. 4 equals 4a, divide by 4, and a equals 1. So now I just reflect back. I've got my general form. I've got that a is 1 in this case, and I've got h and k. So I can write the standard form of the equation. F of x equals a parentheses x minus h in parentheses squared plus k, and so f of x is 1 times x minus -4 in parentheses squared plus 11. So cleaning that up, f of x equals x plus 4 in parentheses squared plus 11. And there is that answer as we go. So that was 4a. And then 4b, same kind of problem, maybe just a little more challenging because we have some fractions. But if you want to pause this and try that, go ahead. Otherwise, I will work through it right now. So 4b, we have a vertex, which is -5/2, 0. And we have our point, which is -7/2, -16/3. And so this is HK, this is XY, and we'll go through that same process. So I'll write it this way. Time is y equals a times x minus h squared plus k. And so y is -16/3 equals a times x, which is -7/2, minus h, which is -5/2 in parentheses squared plus k, which is 0. This is plus a positive. So we get -16/3. When I kind of figure that out, that'll be -2/2, which is -1 squared, which will be 1. So this is just 1a, or a, and plus 0. So there's what a is. And then when we write this, f of x equals a parentheses x minus h parentheses squared plus k. So f of x equals a this time is -16/3, parentheses x minus negative 5 halves. So I'm just going to write minus negative 5 halves, so plus 5 halves in parentheses squared, plus k, which is 0. So this is our format. One thing I'll say, sometimes people get a little over zealous or over involved and want to kind of do this problem. I'll say it that way, which, you know, you want to square that and you want to multiply by the negative 16/3. But this is it for that problem. That is the standard form of the equation of that parabola. So we do want to know that standard form of the equation of a parabola, just letting you know all year, and often on the final exam there's something related to that as well. Then finding minimum and maximum values. This is the next subheading. I didn't look ahead in my notes on this part too, but it could be the last one unless there's yeah, this is the last subheading, I think. Finding minimum and maximum values, something you should be kind of familiar with already. And so this is awesome. If we were in class and had luxury time, we would complete the square with all variables. Super fun to do. And so if you have extra time and you'd like to do that, awesome. Go ahead and give a little try at that. And you can see there's some familiarity there as you look at that. If we complete the square with this quadratic function right there, then we can rewrite that as the completed square in this way right here as a standard form. And so I'm just going to go over to here, and you know some of this too from the quadratic formula is an alternate version. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so we could split that as minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a also. And you know, you've maybe done that before in another class or something and gotten that minus b over 2a as the x value of the maximum or minimum of a quadratic. So this is what we want to make sure. This is the x and the y, so if you want to write it that way too, it's maybe just a little bigger than this one. But the minimum and maximum values of quadratic functions, so if we have, and I'll write this a little bigger because it's kind of blurry looking to me here, f of x equals ax squared plus bx plus c, then the vertex has the coordinates minus b over 2a, comma, f of minus b over 2a. So really, this second part is just like the y value when you put in negative b over 2a as the x value. And then just to kind of say, if a is greater than 0, then the vertex is a minimum. Vertex is a minimum. And the minimum value is actually the y. The vertex is a minimum, and the minimum value is that f of x value. And the minimum value is f of minus b over 2a. So, you know, when they say, you know, what is the minimum, it's actually that y value. And then the other case, if a is less than 0, the vertex is a maximum, and the maximum value is the y value, is f of negative b over 2a, and it happens at the b x equals negative b over 2a. So just kind of some clarification. If you need to pause that to write a little more, go ahead. One of the reasons I write it is it slows me down. And then here is 5a. And just kind of a question, a problem related to this. The path of a baseball after being hit is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate in feet. What is the maximum height of the baseball? And so so I'm just going to write myself some little notes here. An xy coordinate pair is x is the horizontal distance from home plate, distance from home in feet, and y is f of x is the height of the baseball, height also in feet as we go. So we're talking about, you know, here's the little person and, you know, they just hit that and it's kind of going like this. And, you know, we want to know when did it get to the maximum height as we go. And we have this rule, f of x equals negative 0.0032x squared plus x plus 3. So just a reminder, a is this decimal, negative 0.0032. B is 1 and C is 3. And so we know that it's negative, it's a maximum, you know, it's a baseball. We have a lot of familiarity with that as well. And so now we're going to find our maximum x would occur at minus b over 2a. So minus 1 over 2 times negative 0.0032. And you know, try that on your calculator just to see what you get, because sometimes people type that in wrong. So if pause this, try it, and then see what you get. So x is equal to 156.25 feet. And make sure that that's what you get when you do that problem. And ask me in class if you're unsure. So then to find the max, we're going to find f of 156.25, and so that's going to be our negative 0.0032 times 156.25 in parentheses squared plus 156.25 plus 3. And again, maybe take a minute to do that on your calculator. I'll write a few things to set up my answer. And if you've tried that, you should have gotten 81.125 feet. 81.125. And we want to be able to give a meaning to this. And so we can say the maximum height occurs or is, I'll say is, 81.125 feet, and it occurs. So x is the distance from home plate. It occurs 156.25 feet from home plate. Home plate. And so that kind of wraps up that problem, and just being able to kind of try that as you go. So the last one here is 5b, to rework the problem when the path of the baseball is given by this function, f of x equals negative 0.007x squared plus x plus 4, and I'll leave that for you, and on the slides I'll put the answer so you can check that on the PDF of this lesson. Otherwise, and I'll just move ahead right now, you should be able to analyze graphs of quadratic functions, write quadratic functions in standard form, and use the results to sketch graphs of functions, and also find minimum and maximum values of quadratic functions in real life applications. And I would say maybe that was the baseball one or something. That concludes 2-1, and you should be working on homework 1 of this second chapter. If you haven't gotten a homework sheet in paper form, email me, let me know, and certainly if it's not on the YOLO site as a PDF. Have a great rest of your day.